И ничего не меняется. I'm trying to find out what is the difference of the capacitance if I keep the capacitor in my hands, and now I'm gonna release that from my hands. It stays the same. Okay. Keeping, and now I'm gonna be switching the parameters of the capacitor. Okay. Okay. Nothing has changed. Nothing has changed. And now I'm gonna release my fingers. So I put it here, right? And nothing has changed. So now I'm gonna change to it's Z L, which would be a inductive factor. Okay, now I'm gonna put it to my hands. Pretty steady, and I'm gonna keep it, and now I'm gonna release that from my head. So I'm gonna put it here, but before I release that, I want to see what it shows. So I'm now releasing that, and there is no change. What I have noticed is that the temperature that it shows on this device is a set temperature. It's not the real temperature. So with the time, the temperature of the air would be temperature of said in here, but actually says in here solder, desolder temperature, so it's not that. Hot air gun temperature, so it looks like a hot air gun temperature is 50 degrees. Yeah, basically I find out that it is 50 is the pressure and 100 is the temperature of the hot air gun. 100 это есть температура гана, 50 это есть давление воздуха. So what I was doing in here is I was pushing the buttons. I didn't know that I'm pushing the air pressure change instead of just changing the temperature. The two upper buttons are responsible for the temperature. So again, the temperature is 100 degrees and the pressure is 46 right now. Will be Z. Okay, so we have, okay, so now it is showing us the Z is impedance. So it's impedance right now, and the angle, and see how that is going to react. Okay, so I'm putting my gun in here, hitting it from the same distance, and see how it changes. Okay, so the impedance the impedance decreases, the angle stays the same, but the change is not that big. Okay, 92 ohms. One hundred, 102. I'm gonna check how am I hitting it. Oh, I'm hitting it pretty nicely. Pulling factor, because we're not hitting it any longer. Let's see how that changes. So it takes a little while, and then I switch to C. Okay, which is our capacitance. It takes a while before that returns to. So my understanding is that when we deal with the ceramic capacitor, just don't let it heat from the other elements. If you have an ambient temperature, whatever the temperature is, it's gonna hold to its values. And putting the fingers on it doesn't really change anything. It's still warm. I can still hold it in my hands. 68 nanofarads. Better off is to deal with this kind of capacitor, although both legs of this capacitor are broken. I simply dropped that, but this one should not really be so much vulnerable. '71, '72. Yeah, it takes the time after heating to come back to its real value. Okay, let's see Q, how the Q is changing when the capacitor is cooling down. We can also go to the series equivalent. Right now we have been in parallel one. So, hold on, here. Parallel. So we've been doing a series. Now we're gonna go with the parallel one and hide the scale. Okay. 76 with parallel. The Z is 83 ohm. The L is 526 microhenry. We see the pattern. So the inductance is decreasing. We change to D. D stays pretty much the same. Let's analyze for a moment at the end of that video what are we dealing with. We have a Wayne Kerr Precision Magnetic Analyzer, model number PMA 3260A. This instrument is capable of showing a parallel equivalent and series equivalent. I'm changing it right now. The scale, you can activate the scale, hold on, with that. Now, it is showing me that the DC bias of 1 milliampere is off. We have a 720 millivolt AC, and we're dealing with the frequency 25 kilohertz right now. Although I can go anywhere from 0 to 500 kilohertz. Range is auto. Speed is slow. ALC is on, and global setup, which is not really important in here, but I can go to a setup values, instrument status. Just for the quick it shows what do we have set in here. Good English self-calibration device. If you don't do it for a few months, it will protest and stop working till you do calibration. This device does not need any other calibration but calibration by itself. Pretty much nice. Okay, I'm going to that. From the future, you can have the impedance, right, transformer, the primary, the secondary. Of course, all of this is not showing anything right now. Leakage secondary, capacity between this primary and this secondary. Insulation, I don't have this option. I have a calibration, which is a trim calibration, so no way for me to have any error if I do it properly. Okay, and that's all. Thank you very much. Oh, trim error 440 femto. Femtofarad. Can you believe that?